Welcome to another session of Unreal Engine 4. Me and my friend Strange Bro Jim try to learn how the Unreal Engine works. Yesterday we finished the artist's quick start, and today we're gonna start off with the programming quick start. Now, mind you, my knowledge on C++, which is what Unreal Engine works with, is pretty much non-existent. So I'm probably the one who's gonna struggle the most with this, since Jim does have a little bit of knowledge over it. So, speaking of, I might as well hop on over to his Discord stage. He's already almost up on his end.
I will be back in just a minute.
Looks like something came up. Anyway.
Okay. Sorry there, Blackheart. I just started up the recording for it. Be there in just a second.
Okay, we can wait for him in the meantime. Alright, they're not so loud. The description below you will find
proper intro for this.
Alright, let him do that.
I take it that you're probably like working on my channel and going, oh, he's done. He's ready. I need to get started.
Nice. Description below is a link to Power Shop where you can buy energy mix.
Once I hit about a minute, I'll come back.
And shakers, and I know this is a bit scuffed because I jumped into this and forgot to do that. If you use creator code Blackheart, you can get 10% discount on any of your purchases over on Poggers. That's just in my head right now. It's mush because I was busy with other stuff.
Let's get into an intro here. Okay, let's go ahead and get started on this, everybody. Welcome back to another Unreal Engine video. I'm your host, Strange Bro Jim, and we're going to be continuing on with our project for, well, learning some Unreal tutorials, maybe get some tutorial projects done, figuring out, you know, maybe build a little mock game or so to kind of start off with, figure some things out, and then we'll probably be going into designing a game for ourselves. With that in mind, let me go ahead and invite Blackheart in to speak. Let's take care of that.
Hello.
Hey there, bud. How's it going?
I'm doing A-okay.
Sounds good. Sounds good. Okay, so we're going to be tackling the programming side of the Unreal Engine today. The programming quick start, which we didn't like go through yesterday because it was like, you know, we had like 15 minutes left. And I'm like going, yeah, probably not the best time. We'll try to rush through, you know, like the required setup or something like that. So, not exactly something that would be helpful. So, okay, let me go ahead and get the Chrome up so everybody can kind of see that page. So, there we go, programming quick start guide. So that's where we're going to be starting up today.
Yep.
Should I go ahead and read through this beginning area here?
If you like.
Before the record? Alright. In this quick start guide, you will learn how to set up a C++ project in the Unreal Engine and program your first C++ gameplay class in Visual Studio. So we're going to be needing Visual Studio up as well, so look forward to that. By the time you've completed this tutorial, you will know how to do the following. Create a new C++ project, create a new active class in C++, edit that C++ class in your development environment, adding visual representation and functionality, compile your project, and then test your new actor in the Unreal Editor. So this guide assumes that you have already set up your Visual Studio as your programming environment. I mean, we already kind of did that with the artist, but I mean,
Yeah.
you probably should have done that here, to be honest.
Yeah, that should have been on this part, not the artist part.
Yeah, but whatever. We move on. I mean, the artist part didn't really have us doing anything with the programming, so I mean, whatever. It is what it is. We move on.
Yeah.
If not, please refer to setting up Visual Studio for the Unreal Engine for instructions on how to install it and get it set up for programming with the Unreal Engine. We also assume that you have some familiarity with using the Unreal Editor before starting this guide. Well, I mean, kinda. I mean, not completely, but, you know, some, sure, maybe. But for your convenience, we will walk through all the steps necessary to create and manage the C++ classes from the editor. The end product of this guide will be a cube that floats softly in mid-air and continually rotates, giving you a simple object to test as you learn to use the development environment for programming. Okay, so launch the Unreal Editor. You know, I'm assuming that you already have their Blackheart. Matter of fact,
Yep.
let me go ahead and bring your...
Yep, that's the first thing I do before I hit start.
Indeed, same here. Matter of fact, let me go ahead and bring up your stream so that I can keep an eye on what you're doing there. Okay, when the project browser comes up, click Games Project category and select a blank template. Okay, so we're going to be creating a brand new one here. I'm going to have to go to webcam only, so I'm not sure enough. You know, folder information or anything along those lines. I don't want anyone malicious trying to mess with me in some way, so.
Yeah.
And it's mentioned that we are doing a blank template, so.
Yeah. With C++ and starter content enable.
Yeah. Choose your preferred save location and name for this project. So C++ with starter content, a location, and then I'm gonna be changing it to, like, you know, try to go program quick start. There you go. And then that's just a simple create, right? So, yep. Then click create project in our instance. We're naming our project quick start. Oh, how original. It's about as original as what I'm doing it, but this will automatically create a simple blank project with only essential C++ code in the solution, and then it will automatically open inside both the Unreal Editor and Visual Studio. For more information on managing and creating projects, please refer to the project browser page. So we're creating the project.
Oh, great. Sorry to anybody that hears any noise in the background. My dad is using the drill right now. I don't know what for.
I don't know. Obviously, I can't hear it because of the noise cancellation on Discord, but yeah.
Yeah, OBS doesn't have that, which I don't know when they plan on adding something like that. It would be great if they did.
I mean, there might be, like, maybe a mod that you can add, but
I don't know if there's a plugin for OBS. I haven't really looked for it.
Yeah. I mean, we could probably look for it, like, later on tonight if you want, but or tomorrow or whatever.
Because you know we got Warframe.
Yeah.
And well, we tend to lose track of time sometimes there.
Just a few times.
It only happened a few times, only a little bit.
Yeah. It's not like we did that last night or anything. Like, you know.
Oh, yeah, well, maybe you went for a little bit too long.
Maybe a little long. Alright. Everything looks to be up and running on my end now, so...
Yeah, just waiting on mine to decide to finish loading.
Yeah. No worries, my friend. Take your time. Okay, so I'm gonna go ahead and do the finish step on that one, because that's done. So
Yeah, might as well do the
we'll
same.
we'll go ahead and wait for Blackheart to for his computer to catch up. So
yeah, sorry about that.
No need to apologize, man. I already know that. Well, I mean, my computer. You know, I bought a beast of a machine before I lost my job, so you know, so it's it loads everything super quick. So you know. Um, so I'm already aware of that. So no need to apologize. Someday you'll have a beast of machine, and I'll be the one going, oh my gosh, my computer. Who knows?
Okay, now it's opening both Unreal and Visual Studio.
Yeah. As soon as you select the C++, it will kick in Visual Studio for you.
Yeah.
So. Although I don't think I have that source added in yet for Visual Studio. So let me see about trying to add that one in.
I already have I modified the other source for the material one temporarily, since I know we're not gonna be touching that at all.
That wasn't it. Okay, hold on. Let's do studio mode.
Yeah, I just simply don't put it on screen yet because Visual Studio is still loading in wherever Unreal is trying to load into it.
Yeah.
Okay. That loaded in. I'm gonna close this what's new because I don't really care about what's new on that. And re-enable the capture for it. That's not capturing for some reason. Okay, there we go. Now it's actually capturing. I will need to readjust it.
Okay, search screen, putting this right down there. Below the Unreal Engine,
Right
and go ahead and transition out of that. Go out of studio mode. There we go. Oh yeah. So there's the Visual Studio, and then if I minimize this, it doesn't bring up the Unreal Engine. Okay. Maybe because Unreal Engine isn't up. There it goes. Okay. So, alright. So, are you good to go?
Yeah, I'm good to go.
Okay, so you've already clicked the finish step on step 1?
Yep.
Alright, so we're going to go on to create a new C++ class. So in the Unreal Editor, click the File drop-down menu and select the New C++ Class command. So, File, New C++ Class. Okay, so brings up a whole new window for Choose Parent Class. This will add a C++ header and source code file to your game project. So, there's an option of Show All Classes, which is interesting. You can use a none with a default constructor and deconstructor, which I'll discuss if you're not familiar with it. Character, pawn, actor component, scene component, player camera manager, player controller, game mode base, world settings, HUD, player state, game state base, blueprint function library, slate widget style, and Unreal interface. My god, there's so many parent classes that you could choose on this.
Yep.
But I mean, each one of these could be quite helpful. So
yeah, like the player controller one would have you set up with some base code for controlling it already.
Mm-hmm. So, okay, so the Choose Parent Class menu will display. You can choose an existing class to extend, adding its functionality to your own. Choose Actor, as it is the most basic type of object that can be placed in the world, then click Next. So,
Okay.
so we're going to be selecting Actor, and Next. Okay, you guys aren't necessarily seeing this window. At least I don't think you can. I hope not, because it's showing information right at this moment in time that I don't really want to show. Okay, good, it's not.
No, it's not capturing that part.
Alright. So, name your actor. Name and enter a name for your new class. Class names may only contain alphanumeric characters and may not contain a space. So you want to use like underscore if anything.
Underscore or camel case.
Well, I mean, if you want spaces in your naming convention, but typically you don't really even want to use that. You just kind of use like camel case, or maybe not. It depends on the naming convention that you or your company wants to use, obviously. But
yeah, the most common one being the camel case.
Right. Okay, so in the name of your new actor menu, name your actor floating actor, and click class, or click create class, I should say. So we're doing floating actor. Your class name may not contain a space. Oh, sorry. I wonder. Yeah, underscore should still work. So, okay, but they didn't want us to kind of choose and change anything else here. So, so bear that in mind. It already selected the quick program quick start, or the name of your project.
Yeah, the location of where it is by default.
Right. Choose the target module for your new class. That's basically what it's saying there. It's giving you whether or not you want to make it a public or private class. So that's something that you'll need to figure out. Or we'll need to kind of figure out more. As we're kind of making this. They're not really having this change anything right at this moment in time. So, I mean, we could still change it in the code itself, but I mean, if they're allowing for you to, you know, say, hey, I want it public, or hey, I want it private, you know, this is a good way to kind of do it right there, right at the very beginning. It wants you to choose a folder, which, I mean, if you're creating like a whole bunch of actors, then you might want to have like an actor folder. So you might not want it to be in like the main folder that has like all the files in there, right?
Yeah, an actor or reusable code if you're something you're going to reuse in multiple projects.
True, true. But I mean, if you're going to be like reusing the code in like another spot altogether, then you're probably not going to be. I mean, you could still maybe like move the file to like another folder afterwards or something like that, to be kind of reused in other projects. But you know, you don't really want to reference that file from like a different project. Like, you know, you don't want to reference another project's file, you know, from another project, uh, like use an old project's file for your new project's file. You get what I'm saying? Because it might have some additional library settings in there that you might not want to keep, and it might want to try to create some connections to your old project in some weird way. So you don't really want to do that.
That depends on the structure of the code, mostly.
Yeah. But, you know, I'm just putting that out there. So, okay, so you create the class, the Unreal Engine will automatically compile and reload with your new class selected in the content browser, and your programming environment will automatically open with floatingactor.cpp. So,
Show that window for any changes.
Have you already done all that, or is it working on it right now?
It's creating.
Okay. Interesting. Okay, so I'm getting a little bit of a window pop up here. The project program quick start has been modified outside an environment. Press reload to reload the updated project from disk. Press reload all from all external changes and operations are complete to reload all items from disk. Or press ignore to ignore the external changes. The changes will be used the next time you open the project. So, actually, I'm not quite sure what the best selection in this would be in this particular case, because I mean this was built from an outside source, so you would think that you'd want to have it reload. It's been a while since I've touched Visual Studio, so I'm not 100% sure which one to go with here.
Okay, and I'd say play reload all probably. So there's nothing else what we're adding, it's just adding the first new file to it.
Yeah. I mean, it just hasn't been saved. That's why I'm like, you know, this hasn't necessarily been saved to disk, so that's why I'm like, well, worried about that. But yeah, okay, let's go on and reload all. Okay, just making sure.
I see the code for float already.
There hasn't been any changes per se to the Unreal environment. Let me double check my. Yeah, we have the Unreal Engine here at this moment in time. I'm going to go ahead and switch on over to Visual Studio. And I'm going to go ahead and hide the Chrome browser here so everybody can kind of see the code, just in case. If you want to follow along, I would recommend that you go to the Programming Quick Start as well to kind of see what we're kind of talking about right then and there. So, okay. So now that we have created our C++ class, we're going to switch over to Visual Studio and edit our code. Oh, by the way, we can finish the step for step 2 if you haven't already.
I have.
So in Visual Studio, locate the Solution Explorer, which by default is on the left side of the window, and then use it to locate floatingactor.h. In our project, it will be located under Games, Quick Start, Source, and Quick Start. Or, you know, Games, the game name that you created, Source, and then again the game name that you created. Or the project name that you kind of created, right? So I use Program Quick Start, they use Quick Start. So but the floating actor.h is under the Program Quick Start, with floating actor.h. So you want me to kind of go over the floating actor.h file for you a little bit? Because they kind of populated in with some information like at the very start. Unreal Engine already automatically said, okay, let's put this in. Shall I try to explain it a little bit?
Sure.
Okay. So obviously, with the header file, it's basically kind of telling you this is what you're going to be seeing in the source file. Okay. So if say like you open up the floatingactor.cpp, okay, you're going to be seeing can you open up the CPP file just so you can follow along?
Yep, it's open.
Okay, so under the CPP file, you'll notice the #include and the floatingactor.h file. Okay, obviously that #include is basically saying include this file or this library or whatever, so that it can go to the header file first. The compiler will look at the include file first, handle everything that is, it will compile that file first. It will see everything inside of it. It will manage everything that's going on inside that header file first, before it goes into the main CPP file, okay? Because in the floatingactor.h, the header file, you'll notice that there is a floating, there's something called a floating actor open and close paren. There is a floating actor : begin play open and close paren, and then a floating actor tick open paren float delta time close paren. Okay, that should all be in the header file. Well, actually, I was kind of describing what you'll see on the CPP file, but you'll notice in the header file you'll see, a floating actor open close paren and then semicolon. You'll see begin play open close paren and then an override. We'll get to that a little bit later. And then you'll have a tick open paren float delta time close paren override, semicolon. These calls here with the virtual void, those are basically stating that these functions will be in the CPP file so that we can modify what's inside of those particular functions you know, if we need to. And these are automatically generated from Unreal. Okay.
Yeah.
When we set all this up, it automatically populated all this, right? So, this generated body is a hmm, I'm assuming that it's kind of like a constructor in a way. It's basically going to be calling up uh, some additional information through the engine itself to handle some things. So, um, you have the public constructor, which has the name of um, which typically has the name of the file itself. Although I'm not quite sure why they put like an A at the very beginning of it. I'm not sure about that. That's something new. Or that's something I personally haven't seen before. It might be, it's most likely something that Unreal Engine automatically does. Why? I don't know. But normally, a constructor will have the name of the file itself. Okay, you want the constructor to be the same name as the file name. Okay, if you don't, the compiler is going to have some issues with it. Okay, so you always want to have the file name be the same, for the constructor. Okay. The constructor and deconstructors are really useful tools when it comes to C and C++. Okay. They're a way for you to kind of set up the class prior to even loading up any of the functions below it. Okay. So if you want to have something like a variable that you want to set up right when this gets like generated, say like you're creating a new actor, or you're creating an AI on the field or something like that, and you want to set its height, right? There's like, hey, I want to set this particular AI creature to be 5 foot tall or something like that, right? You can go into the constructor and you can automatically say this actor is going to be 5 foot tall. Okay, and it will automatically generate that actor to be, or that AI to be that 5 feet tall, upon creation right then and there. Okay, that's how powerful a constructor can be. So now obviously if you want to change it afterwards, then you can, but or you can send information into a constructor to change it that way. So like you can have the variable say like, hey, I'm getting the height from an external source, from another source, so when they construct another floating actor in this particular case, they can send in that it's 5 feet tall, and it sets it like right there. So it can be really powerful when you're constructing a new object. Right? Deconstructor is the same kind of thing, but it's not necessarily needed as much, because you typically want a deconstructor if you're like if you need to remove anything from memory. Okay. Anything else like variables or something along those lines, something like an int, you don't really need to worry about. It will automatically be deconstructed anyway. But if you're doing something like you're manipulating sources of memory, then you'll probably want a deconstructor to make sure that you're deallocating that memory source so that it can be reused. Okay. If you don't, and if you're not handling it from another function, that's what causes memory leaks.
Okay? Things like that are commonly used for operating systems.
Well, I mean, even with, well, okay. Yeah, obviously operating systems, but um, say you want to create a um, say you want to hold on to like 20 enemy units all at the same time, then you might need to kind of create yourself like a list of all these units, right? But if one of those units dies, then that memory slot that was there, you don't necessarily need anymore, right? So you might need to remove it from memory. You might need to delete that section of memory so that it can be reused by something else later. You see what I'm saying?
Yeah.
So there are uses to having memory management even inside of a game. So don't think that it's just an operating system
No, it's just that
function.
it's more commonly used on that.
Oh yeah.
And I had to see plenty of it when I was studying it. I really did not like that part.
It when it comes to memory management, it can be very difficult when it comes to C and C++. I will not, I will not sugarcoat it on you. But but here's the thing. That's the reason why C and C++ are so powerful and can be and still being used to this day. Okay, it is what, well over 50 years of a language already,
I
and
don't
it's still
know.
being used to this day. So, um, now obviously other languages have popped up, but guess what? Some of those other languages, they're built off of C. So there's a reason. So, um, matter of fact, that Java is based off of C. Java is built off of C. So, but Java does its, memory garbage collection itself. So it tries to handle um, the removal of objects, the deleting of memory and so on and so forth itself. But it doesn't really do a really good job of that. Or it's not as efficient in it than what C++ can. You have to kind of wait for the deconstructor in Java to remove the memory, where in C++ you can do it automatically. But Java doesn't have memory leaks. So, you know, what do you want to do? you know, that kind of thing. So, um, okay, so in the header, you have 3 files that are also included. Bear in mind. Okay, right at the very top, it has has to include for core minimal.h, game framework / actor.h, and then floating actor.generated.h. Okay, these are all different header files, from other parts of the library. Okay, for this, for Unreal Engine, that it will reference, that you can use, you know, um, but these are pretty much, typically, whenever they do this, pound include at the very beginning there for these files, normally they are pretty much required to run your game. Okay, if you like, minimize the pound include, or not minimize, comment out the pound include core minimum.h, you might actually have some problems compiling your code. Okay, because you're removing parts of what Unreal Engine might have. So now we can look into those files. They're in the Unreal Engine. We can actually look at that code if we maybe. I'm not 100% sure. We should be able to, but I don't know. Um, we should be able to kind of look into those, but normally they're files that are very generalized, very well, not necessarily basic, but they are kind of built for you to change however you need to, kind of thing. Or you might need to call upon the engine in some fashion or another. So, that core minimal, might be something that you may need to reference. Okay, there might be a function within core minimal that you can call. I don't know. Okay, see this begin play override and this tick override.
Yeah.
The override is typically, if I remember correctly, it's basically saying that you are, the tick function here was actually a part of one of these other header files. It could have been part of core minimal, it could have been part of game framework, it could have been part of the floating actor. I don't really know, but the override is typically referring to that you're overriding that function from a previous library or from like a different library. If I'm not mistaken,
Yeah, override's like, okay, take something that's in here and maybe alter it or modify it.
I believe so. I don't.
I did use override on C# when I needed to alter like what's the word in English? Some constructions I had made for a few files.
Mm-hmm.
Maybe a value for it needed to change at some point, and I would have to use override to like, okay, go in, find this particular part of this class and modify it.
Right. That's what I believe is the case. Again, I'm not 100% sure. Yeah. Don't quote me on that. Yeah. But
as for tick itself, from what I know from gaming, like tick is almost like a measurement of time.
Well, if you hover over tick in like the .h file, you'll notice that it says called every frame. So, and every frame, the tick function is called. So if you want to have something happen every frame, then you'll want to have something, you'll want to include it within the tick function.
Yeah, I can actually think of an example that mentions tick a lot, which is Minecraft, for example. Like when you have something that's growing like a plant, it's like saying every X ticks change this.
Right.
So say like they planted bamboo, like every 20 ticks make it grow, like add like another bamboo block on it. That's why it's like considered like a measurement of like time or frames in a way that something might change during that frame.
Right, but bear in mind that frame rates might be super fast. Okay, so while you're saying every 20 frames, no, it's probably more along the lines of the if you want it like every second, then it might be like every 6,000 frames or something like that.
That's why it's like every couple of ticks maybe.
It's a lot higher than just a couple, but
yeah, but that's where you gotta like determine, okay, do I want to put a frame limiter on this or not, and like how much will the tick actually affect the game world.
Right, but think of it this way. When you are looking at an animation, right? Let's say any kind of cartoon that you're watching, right? And you are seeing the animation kind of trying to run across, like they're trying to show a person running, right? Well, every single frame they have to draw, the character in a slightly different position every frame to get to that like running motion, right? That's basically what, the tick is all about. So if you want a really smooth running animation, then you might need a lot of frames to kind of do that animation per se. Okay, you might need to change that, that position of that actor every single frame to make it look like a really smooth um, transition. Now you can make it very disjointed, like you can say like every 10 frames, you want it to move, then it's going to be like kind of jerky, kind of thing. But, that's what, tick is kind of all about. Now, there's two keywords before tick can begin play, right? There's the keyword virtual and keyword void, okay? I want to talk about the void first, okay, because that one I know personally, okay? So the void is typically referring to what, if you put something there at that particular spot, like right before the function, you're talking about what the function is returning. Okay, so if you change void there to say int, then you're basically saying that that function, the tick function, is going to be returning an integer. Okay, but because it's saying void, it's basically stating that nothing will be returned from that particular function at all. Okay, void is basically saying nothing is returned. You don't need to worry about seeing anything returned because nothing is.
Yeah, that's
but if you have
also in C# the same case.
Right. So if you're having, int, string, even an object, if you include floating actor at the very beginning before void, which I wouldn't necessarily recommend in this particular case because it would be like, wait, what? But I mean, if you're using, some other object, like say, hey, I'm returning a square object or something like that from the floating actor tick for some reason. Who knows? Then you can do that. Okay. So, but that's where the whole void is all about. Okay. Now, virtual. I can't remember.
I
haven't.
don't.
I haven't used. I haven't used virtual and that that much, if at all.
Yeah, and I've never seen that myself, so I don't know.
Let's see. Okay, rules for the virtual functions in C++ are as follows. Virtual functions cannot be static. Okay. A virtual function can be a friend function of another class. Virtual functions should be accessed through a pointer or reference of base class type to achieve runtime polymorphism. Prototype of virtual functions should be the same as the base as well as the derived class. They are always defined in the base class and overridden in a derived class. It is not mandatory for the derived class to override or redefine the virtual function. In that case, the base class version of the function is used. The class may have a virtual deconstructor, but it cannot have a virtual constructor. Okay. Okay, so explanation. Runtime polymorphism is achieved only through a pointer, which is definitely a C or C++ construct, or reference of a base class type. Also, a base class pointer can point to objects of the base class as well as to the objects of the derived class. In the above code, the base class pointer BPTR, which are you know, I'm looking at a website that's kind of showing that. A little bit here. I'm looking at geeksforgeeks.org virtual function CPP, just in case anybody's kind of wondering what I'm kind of looking at. The base pointer BPTR contains the address of the object D of the derived class. Right, so derived class. Right. Right, okay. Let me see if there's anything else here. How can I explain it? So let me try to process this a little bit. There's the possibility of you can either reference the virtual, which is like the original version of the function, or you can kind of create like another class of, say, a floating actor, you know, that's kind of based off of a floating actor. So like, for example, say you want to have something like UFO, right? And you want to have that also be, you know, in a sense, a floating actor, but not, you know, with its own parameters or whatnot, right? So you're basically extending the floating actor to the UFO as, you know, as a floating actor, but you might not necessarily, you know, you can still have like the tick in begin play, but you're not using the virtual function in that particular case for the UFO. So, you know, you can make changes to the tick on the UFO, you know, for that class. Okay, so like, say you want to change, you know, instead of having the base class for tick, you know, changing the animation every 10 frames or something like that, for example, maybe your UFO wants to change it every, you know, tick every 5 frames or something like that, right? So your UFOs maybe being a little bit more animated, I guess you might say, right? For, you know, for that floating body, right? So you can have that UFO call its own tick function to run, or you might want to say like, hey, I don't necessarily need to worry about, you know, the UFO's tick function. Maybe I just want to reuse what is already set inside the floating actor. So it will kind of bypass the UFO's tick and go back up to the floating actors tick. If I'm kind of understanding what it's kind of talking about. You know what I'm saying?
I think so.
But then again, I could be wrong. Okay, I believe that's what I'm kind of missing on this. So
Let's see. I think I found something somewhere else.
okay.
Let me read it to you. This is for C++ virtual functions. A virtual function is a member function in the base class that we expect to redefine in derived classes. Basically, a virtual function is used in the base class in order to ensure that the function is overridden. This especially applies to cases where a pointer of base class points to an object of a derived derived class.
Right.
Then it puts me an example of class base public void print, then class derived public base public void print. Later, if we create a pointer of base type to point to an object of derived class and call the print function, it calls the print function of the base class. In other words, the member function of base is not overwritten. In order to avoid this, we declare print function to be a base class as virtual by using the virtual keyword. Just kind of makes it easier to like uh, override something specific.
Right. So,
Kind of like an insurance, a little bit.
right. You can still use that base class, function if you wanted to, but more often than not, it will be overridden, or, you can override it through another class in another way, later on. Okay.
Yeah.
That's kind of what I was talking about like the UFO. Like the UFO would override that tick function, for example, and have it do its own thing. But you still have that floating actor's tick function there as a backup just in case. If you're not like overriding the tick function, you don't necessarily need to, but
It all depends on what purpose that tick is going to fulfill.
right. Like there are some functions where it's like, you might want to just kind of keep it with its with the standard, right? Like, hey, this floating actor will have its gravity set at Earth's gravity, right? And you might not necessarily need to change that for for like another class that is built off of floating actor, like the UFO, right? But then again, you might want it to kind of define its own style of gravity. Maybe um, it has its own gravity that it creates, so it doesn't fall at 9.8 or something like that. Who knows? I'm just saying, that's something that you could do with the whole virtual and like. So, but you won't necessarily see that all the time. Okay.
No.
So just kind of stating that outright. Then you have public protected, and private. Okay.
Yeah, those are like in almost every single programming language.
Pretty much. So, well, not always protected.
Mm,
Public, private, yes.
protected is like the
Protected,
least used. That's why it's not like often seen.
right. I mean, protected is typically for like within that um like within that class structure, I guess you might say. You know, that you can kind of reference things within that,
Yeah,
within
both.
that like class structure, but anything outside of it won't be able to see it.
Yeah, that's applies to both protected and private, pretty much.
Yeah. Well, private won't be seen even, you know, like private will not even be seen like past that class, really.
Nope.
You know, protected will allow for other classes that kind of reference that class to be seen, but that's about it. And public is just anything can kind of see it.
It's like protected,
So,
read only. Public, read and write. Private, none of them.
in a sense. So, but okay. Sorry for kind of going along those lines. Uh, I mean, you have the class program quick start underscore API, which obviously is something that is built off of the Unreal Engine. Um, that's something that it will, um, the floating actor, a floating actor is kind of using that, as a, you know, um, trying to, state what a floating actor is all about. So obviously that has a lot of other library functions and functionality like kind of built into it for the most part. So, that's kind of going over my head a little bit as
Mm.
to, what's all kind of contained in that. That's all. That's obviously not something that you will see on a regular basis when coding in C and C++. This is
Yeah.
something built through the Unreal Engine.
Yeah.
Now, the the colon and the public a actor, that's something that you will see in C and C++. Basically meaning that um, the floating actor is kind of extending the a actor class. You know, so there's an a actor class. Or see the game framework slash actor.h.
Yeah.
That's where it's coming from. The game framework has an actor class, .h, .c++, that it's referencing. That's what that's all about. Okay.
Mm-hmm.
So, the hashtag pragma once. I'm forgetting what that is all about. I know that it's there for a reason. I'm just forgetting exactly why it's there. So, hold on. Let me look that up again. Let's see. Da, da, da. So it's used to replace some defines. Not quite sure what those defines are kind of covering for the most part. been a while, so
Okay. Whenever like pragma once mean like do this once and that's it.
Well, no, so there is what's called the if n define my header underscore h underscore, and then it has a define my header dot underscore h. Pragma once basically kind of removes that need for the if n define and if hashtags, so you don't need to put those in anymore. So now what what those defines do, I don't remember off the top of my head. I can't remember exactly what they were kind of used for. So hold on, let me look this up a little bit more. Let's see. A preprocessor directive designed to cause the current source file to be included only once in a single compilation.
So it's kind of like what I said, like saying, like, do this only one time, and you don't need to do it anymore.
Well, yes. I mean, but the question that I have right at this moment in time is, what exactly is it, containing? Because normally it's, it handles a lot of defined, like contained within it, but I'm not really remembering what exactly is kind of contained within that pragma once. So
From what
that's
I'm
all.
reading, it's like the source code pretty much is what's it's used for. From a wiki that I'm reading that I found in Spanish, and basically translate that small section of it is this that is designed to ensure that the source code is okay, I have to think of a proper word for this translation, is called only once.
Include guards are put around the entirety of the header file. This idiom works to letting the preprocessor skip the entirety of the header file if it's already been defined. Only the first time we include the header file will be undefined. We define this macro inside of the if and def block so that all subsequent copies of the header will not be processed. After processing the then blocks, the code will effectively look like this. We can now include our point HTTP header as many times as you want and as many headers as we want without worrying about redefining our functions or receiving compiler errors. So, program once is a non-standard preprocessor directive which tells the preprocessor to skip the current header if it's already been included. So the goal is to achieve the same effect in our include guards, but more concisely. We can use it like this. At first glance, it's much more elegant than include guards, but we could just use program once in all cases. However, as already mentioned, program directives are not part of the C or C++ standard, so the behavior is dependent on the compiler. So bear that in mind. The once alleged advantage of program once is that it can be faster since the preprocessor doesn't need to read the entire file of finding and matching ndif for if and if directive. So basically, you know, you don't want header files being called or you know, you don't want it to be called over and over and over again. So you use the program once to kind of say, hey, just compile it once, you're done. You know, you don't need to compile it over and over and over again, you know, and cause yourself some compiler errors. So, you know, you can use, you know, the header guards, but, you know, some compilers don't really need that, so. Okay. So, yeah, obviously a lot of information there, but you know, it's probably a good way to kind of, instead, you know, obviously if we'd gone on with their, with what they wanted us to do, we'd be like, okay, you know, there might be some things that, you know, I didn't really remember, and we'd be like going through it and going, okay, well, why, you know? So better to kind of look at the code, remember or know what we're looking at the very start, and then we can kind of go back, you know, continue, you know, going through the edit your C++ class, which obviously at this point we've run out of time, so so we'll need to kind of close it down at this point. But you know, is there any, do you have any kind of questions there, Blackheart, before we kind of call it?
No, not at the time.
Yeah, obviously there's some things that I don't really know, and some things that are very much part of the Unreal engine, such as U-Class. I don't recognize that all. That might be a Unreal Engine. That might be part of the Unreal Engine. I don't know.
Don't know.
But you know, hopefully this will be stuff that might be explained a little bit later in the Unreal Engine tutorial. Maybe, probably not. Who knows? But we'll see. But you know, I wanted to cover at least the basics of the C and C++ for the most part. And hopefully, you know, we have a good understanding of what we're looking at right now, and you know, we won't have any worries about that in the future. Hopefully.
Hopefully.
We may forget. We may forget. You know, you never know. But if we do, then we'll we'll, remind ourselves.
That's why
Or,
cheat sheets tend to exist.
Yeah, exactly. Um, the online web, man, it's there for a reason.
Yep.
Otherwise, we'd be like looking through the book, going, "Oh my God, what? Book? What's a book?" um, but yeah. So yeah, it basically kind of constructed, you know, everything initially for us. Um, so take for example the floating actor.cpp. You'll notice that there's some things here like at the very top it says fill out your copyright notice in the description page of the project settings. So so if we fill out the copyright notice in the project settings or in the description page of the project settings, then the copyright notice might actually be appearing right at the very top of our CPP file. It might actually update it like right then and there. So same with the floating actor.h. That copyright notice might be there, right? So well, shall I hold off on like discussing the CPP part tomorrow?
Yeah.
Because there's obviously a little bit more information here to kind of cover. Not a whole lot, but still a little bit of information. Like, I'm gonna assume that you already know what a float delta time is all about. I'm
Float,
assuming.
yeah. Delta time, a little bit.
Okay. So I'm gonna assume that I will. We can cover delta time more tomorrow if you want to. But obviously, that super, might not be familiar with. Um, the primary actor tick dot b, can every tick equal true? You might be like, what? um, but we might want to kind of cover over the source file a little bit more before we continue on. But we can hold that off until tomorrow. Sound like a plan?
Sure.
Okay. And then obviously we'll continue on with the edit your C++ class, tomorrow. I mean, we're just kind of going over it and going, oh yeah. Myself, I'm trying to personally remember C and C++ because it's been quite a while since I've touched upon it. So, so I needed to kind of remember that a little bit. But, and they might talk more about it themselves in their own quick start. I don't really know. Obviously we haven't seen it yet, so we don't know what all it will cover. But I fear if we kind of cover some of the code ourselves a little bit, then we'll kind of look at it and go, oh yeah, right. This covers that. That covers this. Good. That kind of thing. So okay.
Okay.
So shall we call it?
Yep. Let's call it. I need to get something to eat.
Indeed. And then we got Warframe later on tonight.
Yeah.
So. Alright. So yeah, more code to look at tomorrow. More C++ to look at tomorrow, and it's gonna be interesting. It'll be interesting to see what they do. So, all right, my friend.
No.
We'll call it here.
Yep.
So, I'll see you in like an hour and 10 minutes, hour and a half, whatever.
In about an hour or so.
Yeah. However long you need. So, all right.
All right.
So, see you then. Bye for now.
Okay. Okay, so we didn't progress in the tutorial itself. That's because I don't know anything about C++. Like, some things do seem to be similar to C Sharp, but not everything. Like that virtual part, I had never seen it before. I had never used it before. The Pragma ones, again, C Sharp doesn't use it. That's a C and C++ thing from what I saw online. It's not really used anywhere else. Well, we're gonna dive more into that next time. Right now, I am just closing up everything. So that now I can open VStream and Meteor Shower someone. And let's see. Who is on? Ooh, we got someone doing some Phasmo, which for the month of hearts kind of fading. Got more Spider-Man. So I'm seeing Spider-Man show up here quite often. Wolfie Tank's nearly done with her game, so I know she normally ends around this time, so not her. Let's see. Who should I mute? Let's maybe show Kai. Kai's doing some fast mode. He has only been going on for an hour, and he only has 2 viewers. So I'm gonna send my V-stream viewers over there. Alright, need desktop real quick before it causes any mess with the audio. Okay, slash media shower. KVT. And okay, I'm gonna be in there. I'm gonna be back in about an hour or so with some Warframe with Strangeborg Gem as well. I'm gonna be on random mode mostly, so we'll see what I do then. So goodbye for now, and see you all in roughly an hour or so. Okay, bye everyone.